We are given a list of numbers 3, 1, 7, 4, 9, 2, and we want the biggest one. Our eyes spot the 9 instantly, but a computer can only look at one number at a time. So how do we teach it to find the largest without missing any? Here is the simple trick. We start by guessing that the very first number is the biggest we have seen. Then we walk along the rest of the list. Every time we meet a number that beats our current best, we update our best to that number. By the time we reach the end, our best has been compared against everyone, so it truly is the largest. We take the first element as our starting best. Then for each later index, we check if that element is bigger than the best we are holding. If it is, we replace our best with it. After the loop, we return the best. Let's build it live, one block at a time. We begin by assuming the first element is the biggest we have seen so far. Then we scan the rest, and whenever we find someone bigger, we crown it the new best. Once we have looked at everyone, the best we are holding is the answer. Now let's test it and hit run. And there it is. In the first list, the biggest is 9. In a single element list, the answer is that element. And even with repeats, the largest comes out right. We start with the first element as the best. While items remain, we ask if the current item beats the best. If yes, we update the best, then move on. If no, we just move on. When items run out, we return the best. We touch every element exactly once, so the work grows in step with the size of the list. That is order end time. We only keep one extra variable, the running best, so the memory is order 1. Two things to remember. First, start your best at the first element, not at 0, because if every number is negative, 0 would wrongly win. Second, an empty list has no largest at all, so guard against that case before you begin.